Today we're going to be working on Leetcode question number 312. Burst balloons. You are given n balloons indexed from 0 to n minus 1. Each balloon is painted with a number on it represented by an array nums. You are asked to burst all the balloons. If you burst the ith balloon, you will get nums of I minus 1 multiplied by nums of I plus nums of I plus 1 coins. If n minus 1 or n or I plus 1, if I minus 1 or I plus 1 goes out of the bounds of the array, then treat it as if there is a balloon with 1 painted on it. Return the maximum coins you can collect by bursting the balloons wisely. So if you have this array 3, 1, 5, 8, in order to maximize the coins, we're gonna burst the first the balloon on index 1 of value 1, which is gonna give us 3 multiplied by 1 multiplied by 5. Then we're gonna again burst the balloon at index. Looking over here, it's gonna be the index 2 with the value 5. This is gonna give us 3 cross 5 cross 8. Then we're gonna be bursting the balloon at index 0, which with of value 3, and we're gonna be only left with one balloon, which is 8. Bursting 3 is gonna give us the coins value is gonna be 1 multiplied by 3 multiplied by 8, and the last one is when we're gonna burst the last balloon 8, it's gonna give us 1 multiplied by 8 multiplied by 1. The sum of all these coin values is gonna be 167. The way we're going to be doing it is using memoization and dynamic programming. So first of all, we're gonna have our an array of nums, but that is gonna be or let's say extended nums, which is basically we're gonna add 2 more elements to it, so that we can actually add the value of 1 at the beginning and at the end. So that being said, we're gonna say new int. The length of that is gonna be the nums dot length plus 2. Okay, now we are gonna have another value of n. Basically this is gonna count how many or where exactly to we're gonna be putting the values, like we're gonna be copying the values of nums to this extended num. So for that, for int I, actually just do it x into nums. So every single time we're gonna be putting here is we're gonna be basically copying the values to this extended nums, but we want to make sure that we are doing it when the value is greater than 0. Otherwise there is no need for that. We already have initialized everything as 0. So we're gonna say that nums of n plus plus is gonna be equal to the x. So every single time we are incrementing the n and incrementing the n and copying the values of nums to the extended nums. Once we come out of this for loop, we're gonna also initialize a memoization array that the size of that is gonna be a 2D array, and size is gonna be exactly equal to n, and so it's gonna be an n cross n matrix. Now we're gonna make use of a helper function which takes basically the memoization array, the extended nums, Okay, and the left index and the right index. So initially we're gonna start with our 0th index, and the right index is gonna be equal to n minus 1. What this helper function returns is an int. That's what we're gonna be returning. Okay. Okay, so that extended nums which we extended is, we can just call it nums, and then int left and int right are the two indices we're gonna be doing the dynamic programming on. So the first thing is that the base case is if the left plus 1 becomes equal to right, that means uh, we don't have to process anymore. That is like the ending point, we know that, and there are there are not even like enough elements to process on. So we're just gonna say that if the left plus 1 has become equal to right, just return 0. Okay. Okay, and the other thing is, like, because of we are using the memoization, and the memo array has been initialized to 0. If it is not 0, that means we already processed it. So if the value of that memo of like the left and the right is greater than 0, that means just return it. Return memo of left and then right. No need to process it again. Okay, now we're gonna start our dynamic programming one. So we're gonna initialize our answer equals to 0. Okay, and then basically we have to go through the loop. We have to go through from left plus 1 to the right, or up to the right, and then we're gonna be collecting the maximum uh, answer for that, and then we're gonna be basically setting it, whatever the answer is, we're gonna setting our memo of that left and the right to that answer, and then we're gonna be returning that answer. So the way we're gonna be calculating our answer is that we're gonna go through int I starts from left plus 1, and it goes all the way up to I is less than right plus plus. Okay, the answer is always equal to either the answer itself, if because we don't wanna, we are maximizing the coins, so it's gonna be math dot max of answer, or the next thing is gonna be, again we're gonna be taking the left multiplied by the nums of that I multiplied by the nums of that right. Okay, but we also have to make sure that we want to use the recursion in order to come up with the best solution. For that, we're gonna be actually breaking down the ranges. So we're gonna say it's gonna be helper of the other range is the memo nums left to I plus again the helper memo nums I to right. So we broke down the ranges too, so that we can come up with the maximum coins value. Okay, okay. He said incompatible int cannot be converted to an int. You are right. Okay, this time the answer is not right. Okay, so we are just looking at the ranges here. First of all, when copying the values uh, of the nums to the extended nums, what we are doing here is looking good. And then, oh, we forgot to do one thing. That is that we did not set the value of the first one, nums of or extended nums of 0, which is basically gonna be equal to, as in the problem description they said it's gonna be 1, and also the extended nums of the last one and plus plus is gonna be equal to 1. What? Cannot find the symbol. Which symbol? Oh, over here. Looking good. And it did pass all the test cases.